Hi, welcome to Pre-Algebra, Topic 11, Lesson 2, Analyze Reflections. In this lesson, we'll be able to learn how to reflect two-dimensional figures. So let's start with solve and discuss it. Dale draws a triangle on a grid paper and labels it figure 1. Then, using his pencil as a guide, he draws another triangle directly on the opposite side of the pencil so that the vertical side is now one square to the right of the pencil instead of one square to the left of the pencil. He labels this triangle figure 2. How are the figures the same? How are they different? So, if you look at this pencil, it's right in the middle of figure 1 and 2, and figure 2 is not drawn yet, right? We want to look at this triangle in figure 1 and then map it to figure 2. And it's supposed to be reflection. So it's directly on the opposite side of the pencil. So all these points are going to be the same distance away from the pencil, right? So let's first look at these points here, right? So on top of this triangle, figure 1, and if you look at figure 2, all these points are going to have the same distance away from the pencil. So if we look at the other end of figure 1, we're going to count the distance from the pencil, and then we can map another point directly on the opposite side of the pencil. So that would be our point, and if we connect all the dots, it will be the same figure, just flipped on the opposite side of the pencil. So you can notice this is a reflection. It's reflecting on the pencil. So this pencil would be the line of reflection, and it reflects the figure exactly on the opposite side. So let's write that down. So the similarities would be the side lengths of the figures are the same, the shape is the same, and the differences would be that the directions are opposite, they're flipped, they're not facing the same direction. I'm basically talking about the same thing, but yes, the shape should also still be the same because you're just reflecting. It's the same shape triangle, and it's the same size. It's just facing the opposite side, right? So those could be the similarities and differences that we noticed. Let me know if you notice any other things, put it in the chat. So let's move on to focus on math practices. Dale draws a line in place of his pencil and folds the grid paper along the line. How do the triangles align when the grid paper is folded? Explain. So if we look at this example, he's gonna fold it and fold it by the pencil. And you can see that the triangles are gonna be right on top of each other, right? Because the pencil would be the line of reflection, and then the triangle would be exactly the reflections of each other. So the triangle will line up exactly because the triangles are the same distance from the line, which is the pencil, and sides and angles are congruent. So everything is the same except the orientation. So let's move on. How does a reflection affect the properties of a two-dimensional figure? That would be our essential question of this lesson. So starting from example 1, understand reflections. The client also wants the architect to flip the placement of the grill, putting it on the other side of the patio. Where does the client want the grill to be placed? So if we look at this figure here, house, we see the grill over there, and then we want to put it on the other side of the patio. So we need a line of reflection so that it's exactly on the other side of the patio, right? So reflection is a flip. It's a type of transformation that flips a figure over a line of reflection. So reflective figures are the same distance from the line of reflection but on opposite sides. So we have drawn the line of reflection here, and we're gonna flip this grill on the other side, and the distances have to be the same. So it should probably be here where the grill is right exactly on the opposite side and the same distance away from the line. Okay, so it's been reflected, it's the same distance, and same shape, everything same, but it's on the other side of the line. So line of reflection is the line where you're reflecting it. Okay, so let's look at try it. While updating the design, the architect accidentally clicked on the chair and reflected it across the center line. Draw the new location of the chair on the plan. Oops. So where is the chair? He accidentally clicked it and placed it across the center line that we just drew. So the chair is the one below the blue roof over there. I don't know if you can see that, but the chair the chair is right below the blue roof. So also, it's the same way you're going to reflect this across the line of reflection, and it needs to be on the opposite side, but it has to have the same distance from the line of reflection. So there we go. Here is the new place of the chair directly on the opposite side of the patio and same distance from the line. So let's look at convince me. How did a print image and image compare after reflection? So print image is the one before the reflection, right? And image is the chair right after the reflection. So how do they compare? Same thing. They're the same shape. They're the same chair. We didn't change anything. It's the same, but we just moved it. But it's not just a translation. It is a reflection across the patio, right? Across the line. So everything is the same, but the orientation might be different because we reflected it. It's the same distance. All the points should be the same distance from the line, which means further point would be further away from the line on the opposite side, right? So the figures are the same size and shape, but have different orientations. Okay, let's move on to example 2. Reflect a figure on a coordinate plane. Polygon ABCDE has vertices A, -5, 2, B, -5, 4, C, -4, 5, D, -3, 5, and E, -3, 2. Graph and label the vertices of ABCDE and its image. A, B, C, D, E after reflection across the x-axis. So we have the apostrophes to label the images of these points. So you count the distances for each point to the x-axis, and then you go the opposite way. So the opposite side of the x-axis would be the quadrant 3. The down part, right? So you do the same for all the other points. You count the distances, and then you will be able to graph all these points. Let's look at try it. Quadrilateral KLMN has vertices at K 2,6, L 3,8, M 5,4, and N 3,2. It is reflected across the y-axis, resulting in quadrilateral KLMN. What are the coordinates of point and image? So this is the y-axis. Instead of x-axis, you are reflecting across the y-axis, which is going to be reflected on the opposite side of y-axis, which is going to be on the right side, right? Right now, your KLMN would be on the actually it's on the first quadrant, right? But it's gonna be on the opposite side, which would be the second quadrant, so on the left side. So KLMN's pre-image would be on the right side of the y-axis, and all of them would be on the left side. So counting your point N, 3, 2, is 3 units away from the y-axis, and then you graph it. Let's move on to example 3. Describe a reflection. What is a rule that describes a reflection that maps parallelogram ABCD onto a parallelogram A slash B apostrophe C D? Parallelogram is an image. Parallelogram A apostrophe D, B, C, they're all on the opposite side of y-axis, the same distance from the y-axis. Let's go try it. Polygon ABCDE reflected across a line x equals -2. So we have a different line. Graph and label the image. Is the angle A the same? So if we try to reflect it across the new line, x equals -2, it's going to have these points on the same distance away from this line, and you have to count the distances away. That is not the right graph. I'm going to graph it again. You have to count it correctly. It's not to the y-axis, it is to this line, x equals -2. So B is 1 unit away from that line on the left, so go 1 unit to the right, and A 2 units, E 3 units, C 1 unit. I grabbed C's image wrong again, so 1 unit. Yeah, it could be quite confusing if you don't count the distances correctly. And now we have the correct image. There we go. All the points line up. Is angle A going to be the same? Yeah, the shapes are the same. It's exactly the same shape, the same size. It's just that the orientation is different. Even though we flip it, the angles are going to be congruent, right? So yes, the corresponding angle A with angle measures remain the same in a reflection because the shape is the same. Okay, let's move on. That was it. So key concept summarizes our lesson. A reflection or flip is a transformation that flips a figure across the line of reflection. The pre-image and image are the same distance from the line of reflection, but on opposite sides. They have the same size and shape, but different orientations. So that was our lesson 11-2. We will continue our next lesson in the next video.